Welcome today to our third part of this webinar series here. And I think I'll get to the introduction in a moment, but just in case you haven't been here before, just a quick overview of what we are doing here. So we are having a Build Smart on Kubernetes series where we've already had the first two sessions, the first one on the 6th of July and the second one on the 8th of July. This is the third one in our series here. So please make sure to go and have a look at those if you have not already attended those. And then I will then give information on the next slide exactly how to get access to those and how to attend the next one as well. Okay, so before we go ahead and talk about that in much detail here, I want to just share a few links with you guys. So I think the first one here is the login and sign up for IBM Cloud. So in case you have not already done so, please go ahead and just create an IBM Cloud account or log in with your existing IBM Cloud account as well. Then the next one here is for the tutorial and for the quiz. So what's going to happen is that there will be a quiz at the end of the series here where you guys will be able to take a sort of a quick test where if you do pass, you will then be eligible to receive a badge, the one that you can see on the right-hand side of the screen. So please just have a look at that as well. The quiz will open on Thursday. This upcoming Thursday, and it will run for the next few days and close next week Tuesday. Okay, then next here, this is the survey that you use. Please take a moment to do so at the very end, and then just sort of give your feedback to exactly how the session went, and yeah, so just fill in the survey for us. Then lastly, I want to share a link with you guys so that you'll be able to provision your cluster and follow along with the hands-on session. Okay, so then going back here, as I've mentioned before, I want to talk to you guys real quickly about some sort of basic housekeeping rules. So on the right-hand side, you can see the IBM developer here. Please just click that and follow us to get our notifications for upcoming webinars as well. Then on the left-hand side here, you have the name of this sort of webinar here. Then on the just underneath it here, there's a schedule, right? As you can see, there's sessions here. In this case here, we're on session 3 of 4. If you click on that, it will expand and show you the other sessions, and I will show you how exactly that looks in the next slide. Then as well, if you wanna chat with everyone, please use the option on your right hand bottom corner to go ahead and just send a message to everyone. Please we want to make this session as interactive as possible. Then also as well with regards to interaction, you can use the polls or the ask a question option as well. Then lastly, the workshop resources, in this case here, your sign up or create your free IBM Cloud account is the green button. Please go ahead and click on that, and then you'll be able to log into IBM Cloud account. Then, as I did mention before, we are on the third part of the series here. As you can see, it's the one that it's on Tuesday, 13th, 2021 of July. So please, if you want to sort of access more webinars or the previous ones, just please go ahead and just choose between those or the upcoming one as well. It's on the drop-down list here. Okay, perfect. So with that being said, I think we can actually go ahead and get started. So good afternoon once more, everyone. My name is Busom Kombe. I am a developer advocate with IBM South Africa, and I'm here with my colleague, Karim, who's a client developer advocate with IBM Egypt. Okay. Then I think we'll just cover, I'll just go through the contents real quickly. So what we'll cover today here, first and foremost, we'll talk about a few software development practices. So essentially, we'll talk about continuous integration. We'll then go ahead and talk about continuous deployment, then continuous delivery. Then from there, we'll then move on to our CI/CD framework. In this case here, we'll talk mainly about our Tekton. Then moving on there, we'll then go ahead and talk about a few architectures. Essentially, I will talk about your OpenShift architecture, and talk about our OpenShift Pipeline Crts as well, architecture, and see exactly how that comes into play. Then lastly, we'll talk a bit about our use case, and then I will hand over to Karim, who will show you guys exactly how to get started with the tutorial itself. Okay, then just a quick note before I go into the actual content. If you have any questions, please feel free to post them in the question chat section. Then we'll be addressing those accordingly as we move along. Okay, then so firstly, what I want to talk about here is something called our continuous integration, right? So what this is essentially, it is a software development and DevOps practice, right? It allows us to actually it allows us to work in teams where each developer or the developers in the team rather are able to push code in the main branch at least once a day. So what this does is it allows the developers to actually go ahead and have a more DevOps approach to sort of building software, right? So it sort of combines both the development team and the operations teams as well. And what happens is that we also have automated testing rather, which is done against each iteration of the build. So as you can see on the diagram on the right here, we have our DevOps, we have our microservices here, we have our CI/CD and containers. So all of these here form the basis of cloud native development, and this is essentially what our continuous integration allows us to do. So as a basic rule, what happens is by default, right, every change that we make in our repository triggers a new pipeline build. And we will talk about pipelines in much detail a bit later on. But regardless of how many changes we actually make in the repository, every version of your project needs to be built and tested accordingly, right? So what this does is we have something called automated testing, which is then done to actually which is then done against each iteration of our build. Okay, then going on here, I want to talk about continuous deployment next. So what this does is it is also a development practice, right? But in this case here, it allows us to actually see our code changes to application are being released automatically to a production environment. Okay, so what this does is it allows developers to actually go ahead and write their own unit tests, which will then run with every build, or you can actually opt to use a third-party service to actually do this for you. And this actually, what it does is it ensures your overall maintainability and project quality as well. So yeah, so successful builds rather as well can be automated and deployed into production, right? And the automation here is then driven by a series of predefined tests. And as I've mentioned before, this all talks about us building software and building applications using DevOps approach to software development in that regard. Okay, then I think I can move on here. Then I just want to talk mainly now in much detail about some of the continuous deployment tools that we can find when using CI/CD in our code. So firstly here, I want to talk about something called version control. So what this is here, and it is also known as source control rather, and what it does actually, it helps the overall visibility, right, of a project. When you make updates and changes, you want to sort of keep track of those things. You want to see the previous sort of version in case you want to roll back a bit. You want to see the changes that the developers make as well in your code. So this is essentially your version control here. The next, what we have is we have a code review. Okay, so what this does is it is actually a process where we integrate and use tools which then sort of test the current source code that we have. Okay, so what this helps with here, it helps just improve the overall integrity, the overall integrity rather of our software by finding errors or bugs before we actually roll out the changes into production. Okay, then next here is continuous integration, but I've just spoken about this here. Just to sort of add on that, this just helps us minimize inconsistencies, right? When we have multiple developers working on the same project. Then number 4 here, we have something called configuration management. So what this does is it actually ensures that all of our software and hardware sort of maintain something called a consistent state, right? So what that does is it allows us to sort of have a proper configuration and automation of things like our servers, our storage and networking facilities or infrastructures as well. Then number 5 here is something called release automation. So what this does is it actually it is also called application release orchestration rather. It just automates our activities which are necessary to drive continuous delivery, as I've mentioned before, right? Then lastly here, what we have is something called infrastructure monitoring. So this here is essentially a tool which helps you analyze your application's performance, so that when you do make changes to your application, you actually see if those changes have a positive or a negative impact on your overall application, essentially. Okay. Then I think okay, then just to sort of contrast quickly here between development to delivery. So both of these here are development practices, right? But what continuous delivery does is it actually ensures that we have quality assurance in our code, and it automates the building and delivery of our applications rather. And what it does is integrate production like test environments so that you can actually have a simulation of how your application will perform in the actual industry. And what it allows us to do is to limit things like your errors and inconsistencies in your application as well. Okay. I think that should be all with regards to this. Then I think what I will do now is I will just quickly show a CI/CD pipeline here. So as you can see here, what we have on your screen here is a quick sort of diagram which just shows the various steps or stages in your CI/CD pipeline. So of course, what we have first here is the code in which will then be committed into a source control repository. Then from there, we'll be able to have our CI pipeline, essentially, which will build our code, have all the unit tests running accordingly, have all the integration tests running as well. Then the Cict pipeline will then kick into place, and then it will then be able to review the changes and review our current instance of our application. And then there will be a staging process as well, in which our application will then be deployed into production. So essentially, this is how software development is governed by our CI/CD pipeline. Okay, then what I want to talk next about real quickly here is something called Tekton, in which we'll be using in this in our hands-on a bit later on today. So what Tekton is, essentially, it is a powerful and flexible OpenShift vendor neutral framework, right? That allows for continuous, that allows for us to create continuous integration, continuous delivery systems, right? And it also allows our developers to actually build, test, and deploy their code on the cloud or as well on-prem. So what it essentially aims to achieve, it aims to actually modernize our continuous delivery techniques or continuous delivery as a whole, right? So this actually makes our deployment across multiple cloud providers or hybrid cloud environments faster and easier in this regard. Okay. Then just to move on there, and I will touch a bit. I will reference Tekton a bit later on in the next slide. I want to talk nextly about our OpenShift container platform here. So what everyone will be doing today is everyone will have a chance to actually go ahead and provision in a cluster on OpenShift, where my colleague Karim will show you guys exactly how to get started with the hands-on. But just to have a quick overview of how the container platform looks like, we have our OpenShift running on any infrastructure, right? Whether you have your physical, virtual, private cloud, or public cloud as well. Then what happens is that we have our OpenShift essentially being our Kubernetes, but for enterprise usage, right? And then on top of that, what we do have here is that we have things like automated operations using something like a lifecycle manager if you want to go for operators. And then what that allows us to have on top of that stack is things like your developer services, which include your developer tools, automated builds, your CI/CD, and your favorite IDE as well, whatever that may be. And then it allows you to integrate things like your Tekton, your Jenkins, your code-ready containers, in case you want to run OpenShift locally. Then as well, it allows for us to have application services, whether it's your middleware, your functions, your ISVs, and your service mesh as well. Then I think just on that stack as well, we have things like your cluster services, which essentially allow us to monitor, show back, and log certain issues as well. So these essentially include your Prometheus, your Grafana, and your Kibana as an example. Then what this essentially allows us to do is allows us to actually have your best IT ops experience and your best developer experience as well, whether you're using Node.js, PHP. As you can see, some of the frameworks and languages are supported on the very top of your screen here, and also have a Knative or a cloud native development approach to building applications. Okay, then I think what I want to move on now to is our actual OpenShift pipeline CRTs. So essentially, what a CRT is in this case, it will be a custom resource definition. Where in this case here we have some of these which I'll just go into much detail into. So on your left hand side here we have a pipeline, right? And in the pipeline here we have things called tasks. So what a pipeline essentially is, it is a series of tasks. As you can see here, one pipeline can contain multiple tasks in place. So all of these tasks here, what they do is they're executed and allow us to actually construct or build custom complex workflows. Then the task itself, it will be a configurable or a configurable unit in our pipeline. In this case here, the smallest configurable unit rather, or a series of steps which will then be invoked later on to then go ahead and have a specific build, right? And then what it will do is it will map all of our inputs and our outputs to then form our pipeline build as a whole. Then what we have in just in the middle here, we have our pipeline resource, which include our pipeline run. In this case here, what our pipeline run will be is it will just be a running instance of our pipeline that I've just explained on the left hand side. Then in the pipeline run itself, you have a thing is called your task run. So essentially what this is, it is a running instance of each of our tasks, which will then be automatically created by our pipeline run for each of the individual tasks. Then all of these here, they are governed by a Tekton controller, and then they are sort of also in place with things like a condition and triggers, where your conditions would be something like a validation check, and your triggers will be a git push. So as long as certain rules are sort of adhered to or are satisfied, then your triggers will then sort of trigger automatically or accordingly. Then your pipeline is in place. Okay. Then I think what I will move on to now is our use case. In this case here, we want to have an example application where we'll be utilizing Tekton CI/CD for OpenShift deployment on IBM Cloud. And this is the UI on the right-hand side here. And you'll be able to see exactly how to have this running on your own machines or on IBM Cloud rather, on your cluster. Okay, so my colleague will then talk in much detail about how to get started with this. So I think what I'm going to do now real quickly is I'm just going to share some more useful links. I think I've already shared the one here, so it's the one for the badge. So please, as soon as we finish the last session on Thursday, please go ahead and just attempt the badge. Then it will ask you, I think, 15 to 20 questions where if you get a percentage right, you'll be eligible to get the badge, which is the Both Modern Kubernetes World Tour badge. And then just some more useful links here. And what I will do is I'll just share this in the chat section. So the first one here is the IBM Developer Link. Then we have the Red Hat Developer Link as well, where you can find resources on both these links here. And the third one is for learning, the learn.openshift.com and the Cognitive Class AI. So here you can find more courses and more content with regards to many topics from OpenShift, Kubernetes to serverless, and anything else that you guys might want to learn more about. Okay, so I think yeah, I'll just share this. I'll just share this link in a moment. Then lastly, just a quick reminder before I hand over to Karim. This is the third of the series here. So there will be a fourth session on the 15th of July. Please keep an eye out for that. So I think with that, yeah, I'll just hand over to Karim now. Then I'll continue a bit later on.
Thanks, Basiso. Hi, everybody. My name is Karim Dev, and I'm a client developer advocate at IBM. And today we'll be doing the hands-on part. So I'm just going to share my screen. And basically, the very first page we're going to look at is this page, which is for our series. So the Build Smart on Kubernetes World Tour. This is the link. I'll paste it here at the bottom as well in our chat. That's the link. That's basically like our homepage for the series. It's got all the nice labs. You can see the replays as well. So you can go to the lab, go through the lab. You can see the replays in Crowdcast. So the first one was Introduction to Red Hat OpenShift using Go. The second one was Introduction to Operators, and that's what we're talking about today. In our lab, we're going to be using one of the operators called the OpenShift Pipelines, which is based on the Tekton framework. So that's lab 2. Lab 3 is us, Introduction to Red Hat OpenShift Pipelines. So here you can click on Start the Lab, which opens up a really nice PDF document. And this is basically the steps that we're going to be going through. So the very first thing we need to do is to create an IBM account. So that's the very first thing we need to do. So how do we do that? We have a VCPI link that we pasted up on top, but I'll do that again. So the very first thing we need to do is create, using this link, if you could, to create an IBM Cloud account. Once you have that, then the next step is to go to where you get your free clusters. So OpenShift, we have reserved specific OpenShift clusters, which are really kind of big clusters that I'll use a lot of resources. So they're specific for this workshop today. So after you've created an IBM Cloud account, you go here to this link, which is for the clusters, and you put in your IBM ID and the key. The lab key is OS Lab, and you press I agree and submit. And it takes a few minutes. Once it's done, you need to check your email. So this is where it's kind of new. You'll have an email that looks like this, and you just click on Join Now. Once you click on Join Now, then you'll be automatically redirected to IBM Cloud, the homepage for IBM Cloud, which is this page, and you'll get an OpenShift cluster that looks like this. So where is that? So inside IBM Cloud, if you go to the left-hand side, you may need to go to the right and make sure that it says Advo. You'll have here what's called an account, like I mentioned, account called Advo, and you click on that. And then on the left-hand side, you can just go to OpenShift clusters. And for you, you'll only see like one cluster. So like this document, you'll see one cluster. Under the cluster section, you'll have one cluster. So here for me, I have, for example, this cluster. So you click on that. And this is basically getting you into OpenShift. So really easy, just takes a sec to come up. Once it's up, you click on the top right here where it says OpenShift Web Console. This web console is, you click on that and it opens up this page. This is like the home page for OpenShift. This is Red Hat OpenShift. This is now you have a cluster, an OpenShift cluster. So we'll go back. So we know this is the main page. We click on Start Lab 3. It opens up a PDF. And now we'll go into the document, which says basically that you'll have an IBM Cloud account here, and you should have an OpenShift environment. So what's the next step? The next step is we'll look at OpenShift. It's really easy. On the left-hand side, you have like two perspectives, two views. We want to be in the administrator view because what we're going to do is we're going to install a product called Tekton. So first of all, what is Tekton? So if we go to the CNCF, so this is the CNCF, the Cloud Native community. So in Cloud Native, this is what's called the landscape page. These are all the open source solutions that are supported by the Cloud Native Foundation. And on the right-hand side here, you'll see GitLab Jenkins, but you also see Tekton. So if I click on that, it'll show Tekton. Yeah, it's one of the open source continuous delivery solutions, which is part of CNCF. So it's on Kubernetes, on OpenShift. If you click on that, tekton.dev, that'll open up the homepage. So this is the homepage of Tekton, which OpenShift Pipelines is basically an implementation of Tekton, or kind of an enhancement to Tekton, or it's based on Tekton. So if we go back to OpenShift, on the left-hand side here, we'll make sure we're in the administrator perspective. Then we go to operators. Then you have what's called an operator hub. You click on that, and this is where now you can install a lot of products inside OpenShift, container products. So by lots of different suppliers, providers. So for us, just like in the tutorial here, it says we want to select, we scroll down a little bit, we want to select to install the OpenShift pipeline. So that's all we need to do. So we go to the operator hub here, and we click on OpenShift Pipelines, and then we get this. So you just click on that. You'll have an install button here. You just click on it. You select the default installation. It takes like 2-3 minutes to finish installing. And once it's installed, it'll appear on the left-hand side under installed operators. It'll look like this, Red Hat OpenShift Pipelines, and I'll say succeeded. So now we installed what you can call as the Tekton continuous delivery component inside OpenShift. And in OpenShift terminology, what we've done is we've installed the OpenShift Pipelines operator, which is built on Tekton inside OpenShift. So that's it. So now we're ready to go ahead and start working with it. So how is OpenShift, how does it work? It's basically like hundreds of containers, which are basically instances of an image. So you want to group containers together. So you group them together using what are called projects. So on the left here, we can create what we can call as a project. And that's what the next step is. So in this exercise, in this part of the exercise, we install the OpenShift operator, which takes just a few seconds. We make sure it's installed. Let me make this a bit bigger. So we make sure it's installed. It says succeeded. And after that, we want to create a project. So creating a project can be done from the UI. So inside the UI, you can just click on projects, create a project. You can do it this way, or you can do it the more kind of developer way, the kind of the command line way, the CLI way, which is really nice. So how do you do that? If we go back to IBM Cloud here, anywhere on IBM Cloud on the top right-hand side, you have what's called IBM Cloud Shell, which is like a Linux environment, a Linux terminal, which has all of the command line tools like the OC, which is the OpenShift CLI. So it saves you a lot of time. You don't have to install this stuff locally. You can run it. And it also has Tekton, which is called TKN. It has all the CLI tools. So all you do is you just click on this button here, and that loads the IBM Cloud Shell. Now we go back to OpenShift. And if we don't want to use the UI, we want to use the CLI, the very first thing we need to do is log in. So the top right, very, very easy. We just click copy login command, which will give us like a token that we can use. So of course, it'll be custom for you guys. Everyone will get their own unique token. So it'll just take a second to generate. And then we click on display token. And then we'll notice it uses the OC command, which is the OpenShift CLI. So we just copy this whole line, and we go to the nice tool, the IBM Cloud Shell, which I have open here. And let me try to make that bigger a bit. And we just paste it. So we paste it, the OC command. And then it should say that I'm logged in, and I have 68 projects. So now we want to go back to our exercise, and it says you can do a command called OC new-project pipelines tutorial. That'll create a new project called pipelines tutorial. And if you have trouble copy and pasting here, this is really coming from a GitHub repo. So what I'm going to do is I'm going to paste the GitHub repo, which will make life easier for you to copy and paste. It's the same information. So here we can make this bigger. And if we go here, we want to do OC new project. So you can just click on the right here, copy. You go back to Cloud Shell, and you paste it. Just had an extra $sign. So just OC new project, and I can say 03. And it should say created. It'll take a second, and it'll say created. It's still working. Once it comes back, it'll say created, and then it'll appear under projects here. If we look at the word pipelines, now we have two pipelines tutorial, pipeline tutorial 2, which I made before, and now we have pipeline tutorials 3. This was just created by this command, OC new project. It says, yeah, it's created, everything is good. So now we can just do clear, clean that up, and then OC project if we want. That'll show us what project we're in right now. It'll have an asterisk. So when you create a project, you automatically are in that project. So I just don't want to make things too hard. It's really simple. So by default, now you're going to be inside the pipeline tutorials 3 in my case. It's just a bit sluggish today, the environment. Next step. So the next step here is where we can basically go right to developer topology, and then we're installing what are called tasks. So here is now where we got to talk about a few things specific to Tekton. So if we look here on the left-hand side, because under installed operators, we have Red Hat OpenShift, this gives us a new navigation menu, link on the left called pipelines. If we click on that, we'll see that we have what are called pipelines, tasks, and triggers. So if we click on pipelines, we'll see this is empty because you have to select the project. You have to select the project. So I'm going to go to my project, which is called Pipelines 3, for example. Pipelines Tutorial 3. I have no pipelines. I can create a pipeline this way, or again, I can use the command line way. And that's really going to help now because there's a lot of parameters to enter. So you want to have a script to automatically create what's called a pipeline. A pipeline is basically like a set of tasks, like in the old days, like a Java, maybe a POM file, or in C, like a make file. Just a bunch of steps. What am I going to do? I'm going to git clone. I'm going to clone the repo. I'm going to build. I'm going to compile. I'm going to create a deployment artifact. I'm going to, and so on. So these are kind of like the steps that you do in build and deploy, but we do it in Tekton using what's called a pipeline. So if we go back to here, well, we have some built-in ones. We have some ones that are already written for us. So we're just going to copy these. I'm going to copy that just to show you what that looks like. So here, this comes from OpenShift, the pipelines tutorial. This is what's called a YAML file, yet another markup language. YAML is the language or the instruction set that's supported by OpenShift. So in OpenShift, we can say OC create. We want to create something in OpenShift. What do we want in OpenShift? We want over here in pipelines, we want to have a new pipeline here. And we don't want to click create and do everything by ourselves. We want to have a script that's already made. What does this script do? This script basically creates what's called a workspace. So it's kind of like, in the old days, a build machine or a build space, a scratch build space to build, to compile your work, for example. And then you have what are called steps. So this is a task. This whole file is one task. It has a workspace that it's associated with, and it has steps. It has one step, which is called the apply step. What is it going to do, this apply step? Well, continuous deployment means that every time I check in some code, I push something in, I automatically want to deploy. So now I'm dealing with images. I'm dealing here with images. So every time I update an image, so me as a developer, I work locally, I get everything working really nice, and then I push my image. Where? To my image registry. So you have kind of two ways of working. You can work like in GitHub, where you write code and you check in your code. But sometimes you manage your code and everything, and you create an image, and you push that image into, for example, Docker Hub or Quay, and you have different tags, different versions of the actual image. And that's what we're doing in our case. So we have an image. So every time we do an apply, it's going to apply and it's going to pull the latest image from image registry.OpenShift in this case. So we don't want to get too much into that. It's pretty straightforward. It's a classic type of apply step. So we want to run that. How do we run that? we just run this line. So here we just say create here. And we go back to our Cloud Shell. I'm having trouble connecting, no such host. So sometimes let me just refresh this, and I'm gonna log in again. Sometimes things happen. So let me just copy. I'm gonna create another SSH key. Another API token, I mean. Okay, so I just copy this again. I go into here. This is now I'm just logging into OpenShift so that I can run my OC apply command. So now I'm logged in, and I'm using Project Pipelines Tutorial 3. That's good. So we go back to our step, which is to run this line. OC create, we're gonna run this apply task. So here, we copy that, we paste that, so it's gonna create it in OpenShift and grab that YAML file from the GitHub repo. Created, Tekton created. What did that do? Well, let's see. So if we go back to OpenShift here, and if we refresh, it'll appear here as a new task. We called apply manifests, because we know that's what the file looked like. This file is called a task. It's a task. So we create a new task called apply manifests. So if we go back to OpenShift, you have what are called tasks. This is where you have your list of custom tasks, steps in your build and deploy process. You also have built-in stuff. The built-in stuff are called cluster tasks. These already come by default. If you want a task that compiles or does builds and stuff, you can use these. Git clone. So you can use a lot of, it has like hundreds of pre-built cluster tasks, but you can also create your own task. And then you chain the tasks together. Then you run the task. So you run the pipeline. The pipeline is probably going to first do a git clone, get the code, build it, and deploy it. So now let's go to the next step. The next one is going to create, but it's a different file. So let's see what that file looks like. So that file is a task, and it's called update deployment. And it takes parameters like a deployment, an image, a string, and so on. So here we want to run that file. So to run that file, we just do OC create -f, and we paste that file. And it's created. The next step after that is we now are going to start looking at not OpenShift anymore. So we're not going to look at the OpenShift CLI. So before, we were always using OC, which is the OpenShift command. Now we're going to look at a brand new command called TKN, which is the Tekton command. So here you can actually manage your Tekton pipelines. So it says task ls, list the tasks, and we know we made 2 new tasks. Under tasks here, we have 2 new tasks. So we can just paste that this way. And this will list the tasks. It'll show the 2 tasks like it did before. Apply manifest, update deployment. The 2 new tasks. Good, so now we're done. We can show cluster tasks like I just talked about a second ago. But now we want to do the fun stuff now. We want to create a pipeline. Really, really easy. This pipeline is going to go get some code, a front end, a back end, an API GET. So a back end Node.js app and a front end Node.js app. It's going to bring them over. It's going to build using npm, install, build them, and then deploy them in OpenShift. So here's what the YAML looks like. So it's pretty long. The kind here you'll notice is a pipeline, and it's called build and deploy. And it basically manages cloning the repo, doing the builder, which is building the actual image. So you can scroll down here. And basically, we can just use the code here. So if we look at the pipeline, if we go and look at this step, this is the pipeline task. So all we need to do here is run this task, create the pipeline. I'm just going to go back here to the document, just make sure that there's no differences, which there shouldn't be. Here. Yeah, so there is, I remember there is a difference that we need to create what's called a persistent volume. So we need this scratch pad. We need a location to download when we do a git clone, when we download the code, we need a location to run, to drop this data. And how OpenShift works is OpenShift has a really nice feature in storage called persistent volumes. So you basically can have what's called software-defined storage, SDS, and you have what's called software-defined networks. So that's the beauty of OpenShift. Everything is software-defined. So I can create a volume. I can create like a disk and say I want it to be 10 gigs or 20 gigs. And we know that we need a workspace. We'll notice that we need a workspace. So here in this, I'm going to go back here. We're going to look at this file. This file here is creating a persistent volume claim, meaning a request for a persistent volume. So under storage persistence, we make what are called claims. We claim, we say we want to claim this persistent volume. So here we say we want a persistent volume claim, and we want to call it source persistent volume, read write, and 500 megabytes. So that's what we want to run. We want to make as a build area, an area to build, to git clone, and to actually do the npm install or whatever we need to do to build. So we need that. So we do an OC create -f, same thing. OC create -f. So we create what's called a persistent volume claim. So now it says created. If we go now back to OpenShift, we make sure we're inside our project, Pipelines Tutorial 3, that's right. It'll say pending, it'll say like about a minute pending. So you wanna make sure this has to say bound to, before we go to the next step. So that's really important. So that's just one thing, it'll say pending, we have to wait for it to say bound. After that is where we should run the actual building. So here, I'll just wait till it says, I can refresh it. It'll take a few seconds to build, to bind. And if we go back here, the step here now, is to actually create that pipeline. So we're creating the pipeline, the same file we saw. So that's the pipeline. So let's go and try to do that. We really should wait till it's created. Sometimes it's just a bit sluggish. Anyway, I'll have it because I have a backup running of the whole thing. So yeah, bound, there it goes. So it says bound, you gotta wait for that. Bound means, yeah, we allocated 20 gigabytes of software defined storage. That's great. Now we have a scratch pad, 20 gigs that our build process can use, a shared workspace in essence. So let's run the next command, which is create the pipeline. This file, this pipeline. So we just copy that and we go to our cloud and we say OC create -f of the pipeline itself. Now it's created. What did it create? It created a pipeline. So we know that what we're building is called a pipeline. So that means in OpenShift, under pipelines, make sure that you're in Pipelines Tutorial 3 or whatever project you've created, and you have now a build and deploy. That's what's called a pipeline. You click on it, and you'll see, yeah, this looks good. The very first thing I want to do is do a git clone. I want to fetch from the repo, and then I want to build an image. Then I want to apply a manifest. Then I want to deploy it. I want to do a patch and deploy it. This is a pipeline. So what's left with a pipeline? To do runs, to do pipeline runs. Okay, so now let's go back to the documentation. Either documentation is fine. Here we see the build and deploy. It has the steps. This one's a bit less. And here we can also use the Tekton command to list the pipelines. So here we can also view the pipeline from the tkn command. And it should show us the name build and deploy as the Tekton pipeline, because it's called build and deploy. So it'll take a second to come back. Build and deploy, good. No runs, last run, it didn't run yet. We didn't run this stuff yet. What's in it? So let's take a little bit of a better look at what's in this file. In this pipeline, you'll notice that it has workspace, which is called shared workspace. It has tasks, it fetches from the repository. It has a build image. It has an apply manifest. So, but it also has dynamic variables, deployment name, parameter image. So now let's go back to the documentation, and we'll see that this is now kind of the big line. This is the big line that actually is gonna do the actual build. It's gonna basically go and get URL. It's gonna do a git clone of the API, the Vote API. So we can copy that, and just to see what it looks like, this Vote API is a classic file, a Tekton demo that basically is using here a Docker file, and basically this is the backend API. So in this case, the backend API is pipeline votes, and it happens to be a Docker file. So we want to deploy that. We have some code here. We want to deploy that using Tekton. If we look at the other documentation, it should be the same case. That here, it just asks to make sure you add what's called TLS verify equals false. So there is, because this is a tech preview, it's quite new, this stuff. So there's going to be a little bit of things that are a bit different. So I'll show you how to do that here. So here, you just have to make sure you say TLS verify false. Where do you do that? So if we go back to here, and we click on the pipeline, you have parameters. These parameters, you can now add parameters, and it's saying here to say TLS verify false. Why? Because the tool that builds images in Tekton. So if we look at tasks, cluster tasks, it uses what's called the builder. This builder is a cluster task. If we look at the YAML of it, that actually builds an image. It creates an image on the fly. So like Docker builds images, the builder also builds images. And if we look for TLS verify, we'll see that it supports the TLS verify parameter. And when do you use that? You use that when you want it to not verify. So TLS verify equals here params would be false. So I don't want it to verify my keys. You know, images and stuff can have self-signed certificates and so on. So it's saying, no, don't verify the certificate. You know, it's the classic stuff when you're working as a developer in a development environment. You don't have a third-party certificate. You have a self-signed certificate. So you want to add in your pipelines, and under pipelines parameters, TLS verify false. That's it. So we'll go back here. So it says to do that. TKN pipelines ls, but now we want to trigger the pipeline. This is now the main trick here. So here we're going to do TKN pipeline start. What's the name of the pipeline? Build and deploy. Now we're going to pass some parameters, the name of the shared workspace, another P parameter for the deployment name, the URL, and the image. So let's try that. So we're going to try to copy this. And that's pretty cool. In one line, that should go ahead and build and deploy. So let's see if that does anything. So we go back to here, and we paste this very long line. Enter. And while that comes back, we'll wait for it to come back. We'll look at the documentation. It should say that a pipeline run has started. So if we go back to OpenShift and we look at pipelines, we should have a pipeline run that's about to start now. So this has to just come back. It's still thinking, doing its magic. When it comes back, it'll run and start cloning the repo and so on. And we can also view the logs of it. So let's just give it a sec. Just really sluggish today. Yeah, there it is. Pipeline started. Okay, so it's always, I like to use the UI. The UI is really nice. So yeah, it's running. What's happening here? So under pipelines, we see that the build and deploy pipeline is running. It's running. We want to look at the pipeline run. Yeah, it's there. Well, where is it? What step is it in? So now I can say, yeah, it's fetching from the repo. Great. So what's that doing? Let's look at the logs. Now it's in the step fetch from the repo. So it's getting from GitHub. So this will take a few seconds to basically fetch, then build, then apply, then update. So we look at the logs, just let it do its thing, and we can go to the next step because it's another build. So we just finished basically similarly start a pipeline to build and deploy the front end. What we just finished is the back end. bsock vote-API, that's the back end. We want to also do the front end. So this is bsock vote UI. This is a different repo. So if we look at this repo, this is a different repo. This repo is the front end. This is, again, a Docker file, but this is the front end, the vote app, but this is the UI, okay? So we go back here and we copy this Tekton line again. So we'll have two simultaneous deployments or builds occurring, or pipelines technically, two pipeline runs occurring at the same time. This can be a bit of problematic. I've had issues with that because it's a shared workspace and stuff overwrites. So in this case, if you do have any problems, just let one finish before the other one, or create two different shared workspaces, because inside the YAML, you'll notice the shared workspace, there's a delete that occurs. So if things are running parallel, one will delete it for the other. So it's, again, you got to make sure that shared workspaces, you have separate shared workspaces. So for safety, I'm going to wait and let this guy finish. So it's in the build step. So now here, fetch is okay, build. This most of the time is going to fail because, yeah, it says false. That's good. Yeah, it is going to pass. I'm sorry, I forgot that we put TLS verify. Because we put TLS verify as false, we see the parameter made it across here. And now what it's doing is building. It's using the builder, which is a built-in cluster task. That's the equivalent of doing a Docker command, which builds from a Docker file. So you don't need Docker and all that stuff. You have a cluster task that automatically builds new images based on a Docker file. So what's in GitHub? Just a Docker file. And OpenShift inside has the cluster task builder that builds automatically that Docker file into an image. And then the next step is to deploy. So now we're in the build step. So we'll let that finish. Just always safe. I just like to let this complete before I run the second guy, which is the vote UI. So I'll just copy it again, make sure it's copied right. There we go. Copy. And here, I paste that. I'm just going to give it a sec, let this one finish. Okay, so the builder had an issue here. So here, authentication required, Docker image registry, skipping step, open image registry.svc. This should run fine. So this is a tech preview. Sometimes it does get iffy. I'm really surprised because if I go to pipeline tutorials, my pipeline, which is the initial example I made, it succeeds with the exact same code. So let's just run it again. So here, I'll run this pipeline. Pipeline runs. I have a pipeline run here. So if I look at this pipeline run, this is a fetch, a build, and apply. and I can basically rerun it here. So if I rerun this, this is now fetching again from the repo. And just a little bit, takes a little bit of time to run. Yeah, it's cloning now. It's cloning. The vote API. So this is the back end. So we're rerunning the vote API. And probably because I have maybe because I have this same project names or different project names, maybe the same image file. I'm a bit surprised why we got that red, but we shouldn't at all. So I'm sure when you run it, it should be fine. But again, it's a tech preview. It's really new, this stuff, so it's going to have a little bit of issues. It's still in tech preview mode. So we'll just let this build. And this is the vote API, the back end. So what's happening here again is build is running, TLS verify is false. It's building an image from the Docker file that's inside the GitHub repo, and it's storing it inside the internal OpenShift registry. Yeah, so it's still just running here. Copying. So this did it did a commit. Now it's doing a push, so it's fine here. And now it's finished the build image. Now it's in the apply manifest. So it's in the apply phase. So we'll look at that. So it's in the apply. After that, it's going to deploy. And this is for the back end. We need to do the same for the front end. So we'll do that in a sec. Yeah, now it's applying the manifest. It's done. Now it's updating the deployment. It's actually redeploying it, and we'll see where that is when we're done here at this part. There's another view to view the images that are deployed, the containers that are deployed. Okay, so that's done here. All 4 steps are done. So if you go to pipeline runs again, we should have the other run, which was basically the one for the vote UI, the front end. So the vote UI here, I think there's no way to really know except from the logs here. But this is the vote API. I think this one is logs. That's the vote API. That's the first one. Second one. And that's the vote UI, 8T. So I'm going to rerun this. 8T, I can just rerun that here. And I'm rerunning here, basically. This is the vote UI step, so this step. Okay, so for you it should run just fine. And once that's done, we basically are going to actually view what's deployed. So you can look at the logs and stuff, but what we really care about is here. Once it's done, we should be able to view in the developer perspective, which we'll see, topology, and you get these nice circles, these icons. This shows that this is the API container, and this is the UI container. And of course, the UI makes calls to the API and so on. So we're going to see that. That's what we want to see inside your pipelines tutorial project. So here, it did the fetch already. It's in the build step. Okay, just let it finish that. And hopefully when it's done, when this is done, we'll look at in developer and topology, we'll see the two containers deployed, the API and the UI. And then the UI gives us a link, a URL, what's called a route. So we get a URL, like an internet URL that we can click on and see the actual app, and click on it and it should make calls to the back end and come back. And every time you change something in GitHub, anytime you change any of this code, you can just manually trigger. So if you can manually rerun it. You go to pipeline runs and you rerun your task. So that'll do another git pull at fetch. But if you really want, there's another way, which is the best way, which is you can inside GitHub say every time I make a change, what's called the webhook, to notify OpenShift and start the Tekton flow, or the Tekton pipeline. All right, so this one's still running here, this last one. It's on the apply manifest, so we're almost done. About 2 minutes, we should be finished. Yeah, so as I'm saying here, any changes you make in GitHub, you have to come here and rerun the task so that it'll fetch the latest. As another step, you can take it one step further, which is use what are called webhooks in GitHub, and add a webhook to point to OpenShift. So every time you do a push to GitHub, it'll trigger this flow. And that's the ideal, obviously, continuous delivery model. So everything is basically, as soon as you do a push in GitHub, that's when everything starts. Pipelines start. They start when a push occurs in GitHub. So here everything has run. If we go now from administrator to the developer view, we click on topology. Make sure you're in the project pipelines tutorial. We see these two things. If we click on the right, the API. We'll see this is the API, this is the pod, which means container, it's running. We can view the logs. This is some of the beauty of OpenShift. So you can see that the logs are running, that the container is running, and it's called vote. And if we go back to topology and we click on API again, we can see, we can monitor it here, how much CPU it's using, memory. That's the API, the backend. And we can do the same for the front end. So here, if we click on Vote UI, we can also monitor it. We can, in detail, in resources, we can view the logs of the container. You can see, the log it started, and so on. But the most important part is the route, the app. So we can click this little icon, or we can go on the right-hand side here and click the route. This is now the app. This is the app. And when you click on it, one of these buttons, this should call the back end. And that's what just happened now. You clicked here, it went to the back end and came back, voted for cat. So that's basically the application. You have a front end and a back end. And that's really in the document what you should see, voted, cat, dog. And that's this example. And just things to keep in mind is, just make sure you only create one project, not like me where I tried to create multiple projects so I'd have a backup. That's why I was probably getting red. So just create one project, and just because you have the PVC, the persistent volume claim, because it's shared, it's always better to run one build and then the other one. or create two PVCs and change the YAML so each one uses its own workspace. This is kind of a gotcha that I ran into. Had a lot of I spent a lot of time debugging one time, not too long ago. Okay, so I hope you found this useful. So please, guys, try to do the lab. They test your knowledge here. Try to do the quiz. I think it opens. I don't know. I heard the latest was like Monday. Yeah, it's actually up right now. Yeah. Yeah, so it's up right now. You can just click on test your knowledge. And lab 4 is on the 15th, on Thursday after tomorrow. I'm presenting in that one as well, so that should be fun. And that's it. So back to you, Spasiso.
Okay, just give me a moment. Okay, so I think what I will do is I'll just share my screen real quickly and just I have a quick wrap up. So okay. Okay, so this is the last slide. Okay. Okay, so this is the last slide that we had up. So what I will do is I'll just quickly share all of these links here, as I promised a bit earlier on. I didn't want to do that while Karim was presenting, so I'll just share the first one here. It's the IBM Developer Link. So what you can find here, guys, is actually a library of information. You can find tutorials, videos, articles, blogs in here on any of on any of the topics that you guys are interested in, right? Whether it's machine learning, deep learning, AI, Kubernetes, pipelines, whatever else, that just go and search there. You can find resources in there. Then the second one that I'm going to share here is the Red Hat Developer link. So same as the previous one, you can find more resources here. And then the one for learning as well, it's the learn.openshift.com and the cognitive class .ai. So these are all for just for your own enrichment in terms of cloud development and using IBM Cloud services. Then let's see. Okay, how long do we have access to clusters or practice on labs? Okay, I think ideally it should be 2 days. It might be a bit longer because you will have a second session on Thursday. So I think it might just run across there. I'll just confirm. And if in case something goes wrong, you should have a link on Thursday as well for a new cluster. But hopefully it runs a bit longer than that. Okay. Then lastly here, just a quick reminder, as I've just mentioned here, we have our last session in this series here, being the integrate deep learning models into a microservice application, which will be on Thursday, the 15th of July, same time as today, which is 16 100 South African time, or 1800 GST time, as you can see here. Then please just fill in the survey as well. So the survey here will essentially help us sort of know exactly how we did. If you have any feedback, please just take a bit of time and just fill that out. It will be really helpful for us. Okay. Then I think I'm just going to paste the link. Then lastly, what I'm going to talk to you guys about real quickly is Call for Code. So Call for Code has been running for a few months now. It is our annual global challenge where we sort of get developers to come together and work on projects that sort of make change to the world. In this case here, for our 2021 challenge, what we have is we are combating climate change, and we have these 3 focus areas. So the first one here is this, the clean water and sanitation, where essentially we build solutions which govern how water usage is used, or make the water resource and availability and usage and consumption rather a bit much more effective and a bit much more sustainable. Then we have the zero hunger theme here, where we focus more on how we can use technology to help grow crops, as an example, in areas of high drought, or to quickly distribute perishables from small stores to local homeless shelters. So this is our second theme. Then lastly, we have the responsible production and consumption, which is essentially how we can use technology to make changes into which into how energy is being used across the globe and to sort of reduce our individual carbon footprints as well. So these are some of the links for Call for Code here. What I will do is I will share these in a minute. So the first one here is the main page, and where you'll find more information with regards to Call for Code. And then the next one here is the FAQs, where you'll just find sort of some of the frequently asked questions and their answers essentially. Then you're gonna have office hours. I think we have one or two more of those remaining for Call for Code for this year. Then the last one here is the join our Middle East and Africa Call for Code Slack channel, where you'll be able to sort of see other developers post any problems you might have or any issues, and then collaborate accordingly with other people. So guys, just a quick heads up, right? Call for Code ends in 2 weeks time. So it ends end of July. So we still have time to work on solutions. Still have time to sort of build something that's gonna make a change to the world with regards to climate change. Okay, then okay, I think these were sort of mixed up, but that's fine. Then lastly, these are our contact details. Firstly, it's the email address for Karim here. If you have any issues with regards to the hands-on, you can just reach out to either of us, and we should be able to help with regards to that as well. Then these are our contact details for you to reach us. Okay, so I think if there's nothing else Karim would like to add, this is where I will end for today. Before I do end, I will just paste the links in the chat section over the next few minutes.
All right. Thanks, everybody. So yeah, if you guys have any questions, we'll stay like a minute or so if you have anything to ask. About the clusters, they'll be there for I think 24 hours, Amy. Hopefully till tomorrow. I think that should be it. But you can reach out to us if you can send us an email. We can try to maybe extend it for you if you need it for longer. What knowledge is required to participate in Call for Code? Yeah, so Call for Code, it's kind of like a teams. So you're in groups, I think, of 5, and the groups of 5. Yeah, you're welcome, Amy. The groups of 5 for the Call for Code. Yeah, you have to have like some technical skills. You have starter kits that you can use, so you can check that out on callforcode.org. But you can have starter kits to get you going and give you some ideas. But it is pretty techy. Like you're gonna be building, an application or a system. So it's pretty technical. But you can give it a try. I definitely recommend it. About the quiz link, yeah. So the quiz link is at the bottom. I'll give you the direct link to it. It's at the bottom of the main homepage.
I've just pasted it as well, Karim.
Thanks, Patito. Thanks. Yeah, thanks everybody for your feedback. So just please, if you can, give us some feedback on the survey link, it would be great. Thanks, Patito, for all your help. It's been awesome. Do you have guides for COBOL programmers? Yeah, so COBOL, I love COBOL. You know what I mean? It's like the first language from the 60s. I think it's awesome, but COBOL, right? Yeah, for modernization. Yeah, so that's a really big topic. There is, I think, JJ did do something about COBOL. So let me just look for one of our lead developers in Austin. Did something about that. So I'm just looking for COBOL on Kubernetes. Yeah, so he did one in May. So you're in luck, Andy. You're really in luck. So this one's for Andy. This link here is one of our lead developers, JJ, and he did a COBOL on Kubernetes. And basically, OpenShift is Kubernetes, but with hardened security, much more functionality, from Red Hat. But yeah, you can look at his JJ's example. Yeah, and that's all I can really help with in terms of COBOL, really. Yeah, how will we know the group of people? Yeah, so you can call up. You can once you join Call for Code on the links that Spasiso sent, then you can you can. There's a way to look for team members and stuff like that. So you just go on the site and you'll get everything you need, and you'll find a huge amount of participants. So I think it'll be really fun. I did it last year. It was really good. I learned a lot. Yeah. Okay, cool. So if there's no other questions, thank you very, very much. And so join us after tomorrow on Thursday. There's another one on OpenShift and machine learning, which will be really, really fun. Okay. All right. Bye-bye. Thank you.